So today we're going to be looking primarily at some trig application problems. However, there are a couple of warm-up questions here that you may want to try. Notice for both of these questions, these are 45, 45, 90 triangles. So whenever we have those, to ensure that we're in simplest radical form when we can be, please make sure that you use your 45, 45, 90 rules and then come back to check. So for our 45, 45, 90 rules, our two legs are the same, and our hypotenuse is the leg times the square root of 2. On this particular case, our formula says the hypotenuse equals the leg times the square root of 2. So if I know that the hypotenuse is 8, I can plug in what my hypotenuse is and what my leg is. When I divide by the square root of 2, that's going to cancel out. And remember that you need to rationalize that denominator. We cannot leave a square root in the bottom of a fraction. So to do that, we're going to multiply by the square root of 2 on the top and bottom. I'm going to bring this up here just for sake of space. So that becomes 8 square roots of 2 over the square root of 4, and the square root of 4 is 2. And the very last step, divide these if we can, and that becomes 4 square roots of 2 for my y value. Here's a couple of other practice problems with those special right triangles. Again, you may want to pause the video here and retry these. For sake of time, I'm just going to write the answers on the board so that we can get into those trig problems. So this would be 7 and 7 square roots of 3. This would be 20 and 10 square roots of 3. This would be 5 and 10. This would be 2 square roots of 3 and 4 square roots of 3. This would be 7.5 and 7.5 square roots of 3. And then this would be 5 square roots of 3 and 10 square roots of 3. If you have any questions on those, please let me know via email. For sake of time, we're going to move us forward just a little bit here. We do have some practice problems there with trig from yesterday, so do make sure that you've watched the video from yesterday's lesson. Again, today's going to focus on trig application problems, so angles of elevation and depression, as we discussed yesterday or in the notes from the previous day. We also worked through this in the previous video, so if you did not jot that down from yesterday's lesson, please make sure that you go back and watch the end of that video. So, our main goal today is going to be to solve these word problems by drawing our own picture. So it says a couple is taking a balloon ride. After 25 minutes aloft, they measure the angle of depression from the balloon to its launch place at 16 degrees. They're 180 feet above the ground. Find the distance from the balloon to its launch. So essentially, we've got some sort of launch that we started at. It's sitting on the ground. We've got this balloon, and I'm just going to draw a circle. I'm not even going to try to draw that. We've got this balloon. It's currently 180 feet above the ground. So if we want to sketch that here, that's 180 feet. And it says that from the balloon, they're looking down to their launch place. But remember, our angle of depression comes from our eye level. So we're measuring down from that to be 16 degrees. Because of those alternate interior angles, I can bump that down right here. And we're trying to figure out the distance from the balloon to its launch. So from balloon to launch means this is our x value. So if we're looking from the launch as our viewing eye, that's 16 degrees, this is my opposite and my hypotenuse. So that's the SO part of SOHCAHTOA. So the sine from 16 should equal the opposite over the hypotenuse. Multiply by the denominator. we have x times the sine of 16 should equal 180. Since we're multiplying, we can divide by that sine of 16. What we do to one side, we do to the other. Just a reminder here, verify that you are in degree mode before you type this in, or your calculator will not give you the correct answer. So 180 divided by the sine of 16 says that x is approximately 653.0, if we round to the nearest tenth, or 653 feet. So that's how far the balloon is from its launching point. Guys, every time we draw these pictures, they should be right triangles. If not, we can't use trig. So because of that, you could, every time you do one of these questions, start with a right triangle and fill in your information. However, be careful, make sure that you read each situation carefully before you do that. So a surveyor is 300 feet from the base of an apartment building. His angle of elevation to the top is 24 degrees. The angle measuring device is 5 feet above the ground. Find the height of the building. So in other words, we've got this person standing here with this device that's going to allow them to calculate how tall something is. So surveyors kind of figure out the lay of the land. They go through the different pieces that their tiny little computer can do for them. So we know that that tiny little computer, or the measuring device, is 5 feet off the ground. We know that we're looking up to the top of this building with an angle of elevation that's 24 degrees. And we know that we're looking for the height of the building. So I'm going to put this building over here. And I know that I'm currently standing, or the surveyor is currently standing, 300 feet from the base. So because that's the distance at the bottom, I can also put that right here. And what I'm going to have to keep in mind is that my right triangle is right here. So when I set up this trig function, I'm really only finding this information. So I'm going to label that as x, and then once I find my total height, I already knew that this part down here was 5. So my final answer is going to be whatever I get for x plus 5. So I'm going to come off to the side. I'm looking from a viewing angle of 24. This is the opposite and the adjacent. So opposite and adjacent is the tangent ratio. Tangent from 24 should equal x over 300. Since x is being divided by 300, I'm going to multiply by 300 on both sides. So 300 times the tangent of 24 tells us that x is approximately 133.6 feet. Notice here that we haven't finally answered the question yet because we do still have to account for the fact that we have 5 feet here. So if I add 5 feet to that, the height of the building is approximately 138.6 feet tall. Guys, my hint to you is there is going to be a question similar to this on your test, so please put a star by this question, and if you have any questions about it, please let me know so we can go over that together. The rest of class is going to be yours to try some of these word problems. If you need any help, please email me and let me know. Again, today is just an application day with what we learned from the previous lesson. So this should be something that once we have our pictures drawn, hopefully we remember how to finish. If you have any questions, feel free to email me. Have a great day.